So I'm glad to be here. I was a speaker for the very first event, Streaming Tech Sweden, so it was in 2016 or 17. So I'm glad to be here. Good. So I'm Gwendal, I work for Synamedia. I have been a professor at university for a dozen of years before joining Synamedia. So I joined the dark side of the industry. And then I'm solution architect. So it's Synamedia, it's not like pre-sales, it's mostly like innovation, R&D architect. So I'm not that dark, I'm still in the R&D work. And I work for the CDN technology. So we provide CDN technology for private CDN stuff. So first, I just wanted to give a reminder of the motivation for Edge CDN in general. So the internet is a network of networks, which are all stick together via points of presence or internet exchange points. So the content providers can be very far from the end users, and the ISPs have to deliver the last mile, which is often regarded as being the bottleneck. And the public cloud can be as well quite far from the ISP, even if they have more and more connections to the via points of presence. And the public CDN is seen as the way of delivering data to multiple ISPs, so multiple so large areas. But one of the problems of public CDN is that they have to, they are rarely inside the ISP networks, so they have to go through the points of presence of the IXP, and so it can be a bottleneck because the data coming, if you have 1 million guys in the ISP watching the event, you will have 1 million flows going through the points of presence, which means that you need to increase the size of the points of presence, which has a cost. So the solution for this typical stuff is to deploy private CDN into the ISP networks, so that you will have only one flow going to the through the POP, and then the fan out will be organized directly into the network of the ISP. So this is the basic motivation for private CDN. But then it's a different question. So the question will be, regardless of this point of presence problems, should I build a private Edge CDN or should I use a public CDN for this? Both have pros and cons. So the private Edge CDN, you need to pay for infrastructures, meaning that you need to pay for servers that you will deploy into these networks. And these servers, they have a throughput capacity, an egress throughput capacity. And so this egress throughput capacity you need to pay first, or I mean, it's a kind of an investment, right? A public CDN is a different beast because it serves multiple clients, multiple service providers, and so usually you pay for an egress traffic, meaning that you pay for every byte which is actually delivered to the end users. So it's complicated to compare the two different systems. So what we do is that we check what we call the peak to average ratio. So let's consider that we have 1 terabits per second peak. So you need to have a capacity of 1 terabits per second. And the peak to average ratio is how much you use these infrastructures. So typically a peak to average at 10, it means that in average you use 100 gigabits per second, even if your peak is 1 terabits per second. So typically in the previous show, you could see that the peaks can be very high, but there was a very long, very low bar. So this is something which is in average is not used. So obviously if you have 1, it means that you use your 1 terabits all the time, which nobody does. So what we observe is that if you serve TV channels, regular TV channels, you have a peak to average which is around 2 and 4, I mean between 2 and 4. Although if you consider sport channels, they rarely manage to serve interesting content between the games, and so their channels are rarely watched. And so in average, you have a peak to average which can be around 12, 13, or even 15. And so in the case of the TV channels, you can see that the purple line is more interesting because you invest for a capacity, which is for an infrastructures, which capacity is used. So you have an investment which would be too expensive if you use a public CDN. In the case of the sport OTT channels, the public CDN is a better approach because it corresponds to peak that you have. It's regardless of the potential peak problem capacity. So we would like to have something which is in between, which could be an infrastructures, which could serve the average that we have and which could scale potentially for the peaks. So this is what we say that best of both worlds. So having something which is an infrastructure that serves and that can offload most of the data usually. So here we have one private CDN which is deployed in the ISP for most of the content. So this is something that you will not pay for the regular data that you have. And if you have new users coming because there is a game or there is an event which is or simply the peak at 8 p.m., then you will use what we call the providers. So we'll come later for this. And the providers, you put an extra edge servers in these providers to serve for the peak. Okay. And so this is the basic idea, architecture's idea of this hybrid kind of CDN. Okay, so the prerequisite of this is that you first need to find the providers. So the providers should have enough throughput capacity. So it's something which can be hard because sometimes the peaks can be like terabits per second. So you need to have someone who has an infrastructure in the area and which can serve a large amount of data. Another point is that these providers should be capable of hosting CDN software. So it could be, so this is also something which can be difficult because CDN is not just a server, it's a lot of different technologies stacking on top of this. And so the operations is rather simple. So you need to launch servers onto this extra infrastructures when you feel that there is a need for this. You need to reconfigure what we call the delivery services. So the delivery services is typically a channel. So for this, you need to make sure that this new server is known from the monitoring systems, that the gateway which routes the users to the different servers, they take into account the fact that there is this new server here, and to have all the monitoring, dashboarding, orchestration of the system to be ready. So it's not only adding a server, it's making sure that this server is connected to the global distributed infrastructures. And then you need to also connect this server to the logging systems so that it will actually report what's going on in the systems. So a good point is that it will maintain the logging systems together. So 2023 trends that we follow closely. So first, we need to anticipate. So we need to, as I said, it's not just adding a new server. Adding a new server can take 1 minute or 2 minutes, but the fact that we need to connect this server to the remaining of the infrastructures requires some time. So having like 5 to 10 minutes anticipation, if possible 30 minutes, that would be good. So for this, what we can use is time series to forecast that there will be a peak and to estimate what will be the size of the peak. So for this, there are many techniques that comes from stochastics, ARIMA, and this kind of stuff. What we use as well is machine learning libraries. So the ITVX, again, data was very soccer pattern, which was very clear. So you can see that the fans, they start to connect 30 minutes before. and they ramp up, and the peak of the entry point is like 5 to 10 minutes after the beginning of the game, and then they have a steady population. Then you have the halftime, and depending on the game, even it go down or it go up, and you can have an extra time. But these patterns, machine learning can recognize it, and you can include this into the learning of the time series systems, so that you can predict what will be the size of the peak. So you can know simply by watching the 30 minutes before the game, you can know if it will be a 16 terabits or 12 terabits or 20 terabits. Somehow it's possible to do this kind of stuff. And then what you need is to automate the process. You don't want to, I mean, you can send alarm saying, hey, it will be a big peak, and somebody to click on the button. So you want to have this automatically deploying, especially if you have a special event like the queen is dead or something like this. You cannot anticipate, so you need to be able to do it automatically. And this requires APIs, it requires having a lot of different technology for this. The second trend is how to offload. So you need to find providers. So who can be these providers? So the first one could be a public CDN. This is what people usually do. They offload to Akamai, they offload to Fastly, they offload to CloudFront. So now you have new technologies coming. So content steering is one of these new technology, which is very hot at the moment. So you have steering servers that can route the users to the different CDN even during the stream. So it's not something, I mean, the first generation offload was you selected the CDN and you stick to it. Now you can every minute switch from one CDN to another, which is very good for the systems. The new trend is the client-side multi-CDN. It's a bit like the adaptive streaming system. So it means that the one who knows the best what is the quality of the delivery is the client, because it can just get the data. So it can switch automatically from one to another. So these are good technologies which are under development now at SVTA typically. One of the problems is that the CDN do not have the same log system usually. So you need to get some logs and to ingest some logs which can be not the same as what you used to have in your private CDN. It's expensive, and you can still have this bottleneck at the point of presence. So it's not a perfect solution. Another good solution for this would be in the case that the ISP have two private CDN into their networks. And so today there is a lot of work on open caching to offload the traffic to another CDN and to make it easier. So you can, it's simply a set of protocols to make sure that you don't have to renegotiate the protocols for sharing the data to another CDN for every possible partners. So it has the same logging system limitation, meaning that you don't have the same quality of log that what you have with your CDN. You can have also some feature inconsistency. So typically watermarking or even token management systems can be different from one CDN to another, and so you may not have the capacity to do that. And usually at 8 p.m. this CDN is also busy, so when you want a CDN to assist you, the CDN is also waiting for you to assist, so it can be like a starvation problem. And so the third one, which is the one that we prefer on our side, is to have a public cloud providers having data centers, which can be now in the ISP. Some public cloud providers have this functionality, and so in that case, you don't use someone else's software. What you use is you use your own Edge servers, which have been put into a container typically, and you can reconfigure the delivery service into your CDN, but it is the same server as the one that you already have, except that it is running into a third-party infrastructures. So in that case, it could be very good for the logs, it could be very good for the features, it could be very good for the security, the token, and many advantages of having only one CDN instead of having multiple CDN. It can be complicated in terms of Kubernetes. I don't remember who this morning said, hey, we have our own Kubernetes systems. Well, everyone has their own Kubernetes system, so you need to renegotiate all this Kubernetes stuff all the time. You also have some problems sometimes because the hardware is not the one that you have on your private CDN, and so you need to requalify the quality of the servers to know what kind of capacity they could have. And sometimes they also have some bottleneck issues. But so I promised that I would talk about some optimality. So let's, sorry for the light white slide. So it is 1 week of traffic. And so when ISP come to us or service providers come to us and say, hey, I want to have a private CDN. Usually they say, well, my peak is at, here it is, what, 700 gigabits per second. And they say, well, let's do it like a 120% because we want to have a safety margin, we want to have disaster recovery, and it will increase in the futures. So this is what they usually do. And so with this idea of a hybrid CDN, what we do is that we would like to say, no, let's put it at here 500. So you pay for the capacity for this month. So this is the capacity stuff. And the remaining, we will put that into, we will deliver this through these providers that we have. So the volume of data will be paid per month, but it will be depending on the peak that we will have, the length of the peaks, and the number of gigabytes that have been consumed by the end users. And so the question is how to put this bar. Where 500 is good, why not 400? Why not 600? What is the optimal one? What is the one which has the better cost subject to the different constraints that we have? So we did some computation. So I'm back to the dark background of the slides. We did some computation. So on the one hand, we have the traditional Edge CDN, so where we invested into another provision infrastructures, and we have some typical price. It's not quote, it's just some prices we put, but don't take it as at the ground. And we have the maintenance and the upgrades, so we have some price which change over multiple years. And on the other hand, we have this hybrid Edge CDN, where we have this under-provision infrastructures. And so the yellow XX% is how much I will under-provision this network. And here you have always this maintenance for the deployed CDN. And we will have, in addition to it, the increased capacity when it is needed, so during the peaks. And here we have prices, and as you can see, the price will depend in CDNs to the volume, global volume. The more you deliver, the cheaper is the gigabytes, additional gigabytes that you will serve. So it's not a linear function, it's more like a logarithmic one somehow. And so it looks like this. So on the x-axis, we have the size of the on-prem, which is the result of our optimization system. And so typically, it will be at most the 120% of the peak that we mentioned earlier. And on the y-axis, we have the ratio of what is the cost of the hybrid CDN compared to the traditional Edge CDN. So everything which is above 1 is that it's not a good idea to use this hybrid CDN because you use so much of the extra providers that you pay an extra fee that you would not have if you use your private CDN. And everything which is below, which is of interest for us, it is good, meaning that it's cheaper to have the hybrid CDN rather than the traditional CDN. So first observation, it is dangerous. This strategy of offloading peaks can be dangerous because if your capacity is too low, then you will pay much more than if you invested into some capacity. And this is for all the experiments that we did for the different traffic. Second observation is that we can have around 25% savings, cost savings, meaning that we can actually reduce the over 3 years budget for the delivery because you have you found an optimal size for the capacity. And so the optimal size for the capacity, it's something that depends on the ISPs. And what we observe is that it's usually the capacity that is used 95% of the time at peak. So the 95th percentile of the usage of the time, then you check the capacity, and everything which is above is something which is where you need the extra infrastructures. So the optimal offloading is a 3 tuple. One is the max capacity, because if you have max capacity, I mean, you need an infrastructures which can provide a lot of data. Then the second one is the hours per month, because you pay for the extra servers that run into these data centers. And the third one is how is the extra volume of data that you will use from these external infrastructures. And so here are just some example of it, where you can see the first ISP, it has a peak to average 2.3. And so usually the peak is 1.5 terabits per second. And in fact, our recommendation is to go to 1.2 terabits per second to get something around 23% for this one. And the second one is a different computation because it has a different peak to average. So conclusion. First, what I said about optimal capacity question, it is first you need to find the providers. So you cannot do the computation if you don't have the pricing from the extra providers, because it's the input parameters of the systems. The second one is indeed how to under-provision and how to make sure that when you pay for the peak, it works well. And so the calculation depends on this peak-to-average ratio somehow. It also depends on other kind of statistics, but the peak-to-average is a rough simplification of the systems. And you can check your providers or your partners saying, okay, this is the 3 tuple that I have, can you serve it? People usually in data centers, they take it and they give you the price, which is immediately possible to do it. You can expect from there 25% cost saving approximately, but it's subject to the offloading technologies that you want to implement with the pros and cons in terms of logging and in terms of feature that you have in your systems. And that's it. Thank you very much.